Now we need to subtract a single digit number from a 4-digit number. So for this first question, we start with 7,342 and we need to subtract 8. Well, we can subtract 2 to get to 7,340, and then if we want to take away 8 and we've already taken away 2, we need to take away another 6. And that gives us 7,334 as our answer. So notice, if you know that 42 minus 8 is 34, you know that 7,342 minus 8 is 7,334. Now, 4,103 minus 4. So, from 4,103, subtracting 3 will take us to 4,100, and then, because we need to subtract 4, if we subtract 1 more, that will take us to 4,099 as our answer. So if we know that 103 minus 4 is 99, we know that 4,103 minus 4 is 4,099. And here, it's really important that we remember to write the 0 in our hundreds digit to make it clear that this 4 still represents 4,000s, not 400s. Now, 2,000 minus 6 is 1,994. That's because if we have zeros in our ones, tens and hundreds, we know that our thousands digit will need to change as well. So we know that 4 and 6 make a number bond to 10, so that's why the ones digit is a 4, but we need to change our tens and hundreds digits to 9s as well. And finally, we have 3,003 minus 8. Starting from 3,003, we can subtract 3 to get to 3,000, and then to subtract 8, because we've already subtracted 3, we need to subtract another 5, and that takes us to 2,995. So let's take a closer look at these questions. First, we had 7,342, so that's 7,000s, 300s, 4 10s, and 2 1s. To take away 8, we can take away 1, 2, then exchange, then take away 3, 4, 5, 6, 7, 8. So you can see that our tens has changed as well. We now have 3 10s rather than 4, and we have 4 1s in our answer. Or using place value counters to subtract 8, we subtract 1, 2, then exchange 1 10 for 10 1s. Then we can take away 3, 4, 5, 6, 7, 8 to leave us with 3 10s and 4 1s in our answer. Then we had 4,103, but we needed to subtract 4. We could subtract 1, 2, 3, but then we needed to exchange. First, we can exchange our 100 for 10 10s, and then take one of our 10s and exchange it for 10 1s. So then, when we subtract our fourth one, you can see that we now have 4 thousands, no hundreds, 9 10s, and 9 1s. So that's why our answer is 4,099. Or with place value counters, we can subtract 1, 2, 3, then exchange our 100 for 10 10s, take one of those 10s, exchange it for 10 1s, and then remember we've already subtracted 3, so if we take away 1 more, that gives us 4,099 as our answer. And again, it's important that we write the 0 in our hundreds to make it clear that we have 4 thousands. Then we had 2,000 minus 6, so that's subtracting 6 1s, but here we don't have any 1s, and we don't have any 10s or hundreds either. So first, we can take one of our thousands and exchange it for 10 hundreds, then take one of our hundreds and exchange it for 10 tens, and then take one of our tens and exchange it for 10 ones. So here we've still got 1,000, but now we can take away 6 of our ones counters. When we do that, we get 4 ones in our answer, but because we've exchanged, you can see that we now have 9 tens and 9 hundreds as well, and because we exchanged, we've only got 1 of our thousands. Or with place value counters, to subtract 6 ones, we need to exchange 1,000 for 10 hundreds, then take one of those hundreds, exchange it for 10 tens, take one of those tens and exchange it for 10 ones. So then we can take away 6 to give us 1,994. Then for our last question, we had 3,003 minus 8. We can take away 3 of those ones, but then to take away the next 5, we need to exchange, then exchange again, and then exchange again, so that we can take away 5 more ones, and that gives us 2,995 as our answer. Or with place value counters, to subtract 8 ones, we can subtract 3, exchange, take one of our hundreds, exchange again, take one of our tens, exchange again, so then we can subtract the remaining 5 to give us 2,995.